Far beyond the Earth, in the deep cold of space, there exists a moon so strange, so alien, that it defies our very understanding of what it means to be habitable. This is Titan, Saturn's largest moon, a place where the usual rules of life and survival seem turned upside down. And yet, this moon, with its bitterly cold surface and strange, methane-filled atmosphere, holds a tantalizing possibility, the potential for life. But could life exist here, in a world so different from our own? To answer that question, we must dive deeper into Titan's mysteries, its atmosphere, its chemistry, and its potential to harbor life in ways we can barely imagine. At first glance, Titan seems inhospitable, even hostile. Its atmosphere, shrouded in an orange haze, is mostly nitrogen with traces of methane and hydrogen. This thick, unbreathable air is not what we would consider conducive to life. But Titan's atmosphere, despite its strange composition, holds one of its most intriguing secrets. It is chemically active. Far from being an inert environment, Titan's atmosphere is a rich source of organic molecules, chemicals that could one day form the building blocks for life. In Titan's upper atmosphere, ultraviolet radiation from the sun and cosmic rays from space interact with methane, breaking it down into simpler compounds. These reactions create complex organic molecules, such as hydrogen cyanide, cyanoacetylene, and other carbon-based compounds. These molecules are similar to the building blocks of life here on Earth. On Titan, they rain down onto the surface, coating it in a rich, organic-rich haze, and forming lakes of liquid methane and ethane. For life as we know it, this might be an inhospitable place. But what if life could arise from these very same molecules, using methane as a solvent instead of water? Here on Earth, life thrives in water, a solvent that allows for complex biochemical reactions. But on Titan, water is absent. Instead, the liquid methane and ethane that cover Titan's surface might play a role as solvents for life. These hydrocarbons, though radically different from water, could allow for the creation of chemical bonds essential for life, forming a unique kind of biochemistry. Titan's cold temperatures, averaging around -290 degrees Fahrenheit, make this an environment where life would have to function in ways we cannot yet fully comprehend. Imagine life, not as we know it, but as we could never have imagined, existing in a liquid methane environment, using methane in place of water to fuel its metabolism. Such a life form would operate under principles so alien, yet so tantalizingly close to the basic chemistry of life on Earth. Could such life exist on Titan? For decades, scientists have pondered this possibility, with some suggesting that Titan could harbor microbial life forms that use methane in a way similar to how microbes on Earth use water. In Titan's sub-zero environment, complex reactions could still take place, fueled by the abundant supply of hydrocarbons and the presence of liquid methane. Titan, after all, is not a dead, frozen world. It is a world of chemical activity. Some have even proposed that life on Titan could be based on an entirely different kind of biochemistry, one not dependent on carbon-based molecules as Earth life is, but still capable of sustaining the processes we associate with life: reproduction, metabolism, and evolution. Yet, life on Titan may not be a simple answer. Titan's surface is not just a barren landscape. It is an active, dynamic world. Evidence of cryovolcanism, or ice volcanoes, suggests that there may be underground oceans of water heated by tidal forces from Saturn's immense gravity. These hidden seas could potentially offer more familiar conditions where life, based on water, could survive. If this is the case, Titan might be a world of contrasts, one that harbors a cold, methane-rich surface, yet hides the potential for life beneath its icy shell. Thanks to the Cassini spacecraft, which orbited Saturn for over 13 years, we now know more about Titan than ever before. Cassini's many flybys of Titan revealed its rich atmosphere and complex surface features, from its methane lakes to its organic-rich chemistry. The Huygens probe, which descended into Titan's atmosphere in 2005, provided the first direct images of Titan's surface, showing a landscape shaped by rivers of liquid methane, icy mountains, and regions of potential organic interest. But while Cassini's discoveries have illuminated many of Titan's secrets, it has also raised even more questions that continue to fuel the search for life. One of the most profound questions raised by Cassini's findings is whether Titan could harbor complex life. In the lab, researchers are studying how complex organic molecules form and interact in Titan-like conditions. They simulate Titan's frigid temperatures and methane-filled atmosphere, watching as amino acids and other organic compounds form, providing evidence that the building blocks of life could emerge in Titan's cold, chemical stew. Yet, this is only the beginning. The true nature of life on Titan, if it exists, could be completely different from what we expect, existing in a chemistry and a world so foreign to us that we can hardly begin to understand it. To answer these questions, humanity is preparing for an unprecedented mission to Titan. NASA's Dragonfly mission, set to launch in the coming years, will send a rotorcraft to Titan's surface to explore its lakes, atmosphere, and organic chemistry in great detail. Unlike any other spacecraft, Dragonfly will fly from one location to another, collecting samples and gathering data from a variety of environments. Its goal: to find out whether Titan's chemical processes could support life, and whether Titan itself might harbor signs of biology, even if it's not like anything we've encountered on Earth. Dragonfly is equipped with state-of-the-art instruments capable of detecting complex organic molecules, analyzing surface samples, and examining Titan's atmosphere for chemical signatures of life. It will land near Titan's methane lakes and rivers, where the rich organic chemistry may provide the perfect environment for microbial life to thrive. The mission will explore areas where the interaction between organic molecules and liquid methane might create the right conditions for life to arise, or where the chemical signatures of life, past or present, might lie. But the exploration of Titan is not just about finding life on one moon. It is about exploring the very nature of life itself. Titan challenges us to think beyond the familiar. If life can thrive on a moon with methane lakes, what does that tell us about life in the rest of the universe? Could other moons, planets, or even distant exoplanets harbor life in ways that are entirely different from our own? The search for life on Titan opens up the possibility that life is not a rare anomaly confined to Earth, but a common phenomenon present in many forms throughout the cosmos. Every discovery we make about Titan adds a new chapter to humanity's quest for understanding life beyond Earth. If life exists on Titan, it would transform our view of the universe. It would force us to reconsider the very nature of biology, chemistry, and the potential for life in the most extreme environments. Whether we find life on Titan or not, the mere possibility will help us understand more about the conditions under which life can exist on other moons, on other planets, and on exoplanets far beyond our reach. Titan is, in many ways, the ultimate frontier. A world that challenges our understanding of life. A moon that may one day reveal the greatest of cosmic mysteries. As we continue to explore this alien world, we may find answers that will change our place in the universe forever. Titan is not just a destination. It is a symbol of the uncharted realms of possibility that await in the stars. As we look to Titan, to the farthest reaches of our solar system and beyond, we are reminded of how much there is to discover. In the cold methane lakes of Titan, we may find life, or we may find something even more profound. The knowledge that life, in all its diverse forms, may be as common as the stars themselves. Our search for life beyond Earth is only just beginning, and Titan may be the key that opens the door to understanding our place in the cosmos.